All right. I think if we can find if we find yeah, this is a problem, right? After using substitution, if you can simplify this, and maybe you are able to find the answer in the book already. Okay, then it's actually it's negative hyperbolic secant. But in this book, we were trying to. Oh, sorry, it's my mistakes. It's my mistakes. Okay. This is the derivative of hyperbolic secant x is x over 1 minus x squared, so x squared. So I should use that's my mistake. So let's repeat this problem again. So watch out the sign. And when I read the problem, I saw this minus. Okay. So after you substitution, okay, after you use the substitution, you get this. And then you search for this is very special function. Then you search for a formula, and in the formula, there is a formula here on the page 488. Okay, and this is going to be clearly, assume x is use a positive. Okay, assuming you use a positive, then this is going to be there was a negative sign here. Okay, and this is a cosecant, sorry, not the cosecant, yeah, cosecant u plus constant. Okay, so this is cosecant. Then you replace, it's not secant, the inverse of a cosecant. Okay. And yeah, I have to change this. Okay, so in order to, yeah, then you have to, maybe you're able to replace this part. Okay, maybe replace this using natural log. Then the idea is, how do you express the inverse of a hyperbolic cosecant x? So you begin with this equation. Okay, then this is a secant x, right? By definition. So so the next step, then you don't need to solve the equation. All you have to do is yeah, let me get this part. There's some mistakes here. So what you should do is just look at this equation, okay? Then in the book, there's already have the formula here, the inverse of hyperbolic sine x. Yeah, inverse hyperbolic sine x. I keep writing secant sine x. Okay, so x is going to be, okay, now it's correct. Okay. Oops. Okay. Okay, so that is the formula is given in the page. In the place of x, I have to put. Okay. So this is our inverse function. Then you go back. To this is actually the inverse of cosecant. Okay. Then you go back to above integral. It's going to be natural log, and in the place of y, you replace by 2x. Okay, that's the answer. Okay. And this is pretty similar to the one we have here. So you can also use this formula to solve the problem. Okay. All right, so now I'm going to take a look at the following integral. Okay. Of course, we have to get rid of this strange constants like 4 and 5. And so use a substitution, make it as simple as possible. Okay. So the natural substitution you can choose is because 5 minus 4x squared, you take, how do you do that, right? You have to use the substitution and to get rid of the constant. So I take a 5 out, it's 1 minus 4 over 5x squared, right? And then it's a 5, 1 minus square root of 4 over 5x squared. So it's natural to use this substitution. Okay, use this substitution. Okay, let u to be this number. Okay, then x is going to be square root of 5 over 4u, right? Okay, so the integral here becomes square root of 5 over 4u squared, and here square 5 minus 4, and here x is a 5 over 4 u squared, and also dx is going to be square 5 over 4 du. Okay, so now we have to we have to simplify it. Okay, we have to simplify it. Okay, how do you do that? Well, this is a 4. Right? When you square it, it's this 5 u squared, and this is given 4 over 5 u squared, and this is square 5 over 4 du. Okay, you take the square 5 out from the denominator, then you cancel square 5 in the numerator. Okay, so the answer here after simplifying, I think it's a 5 over 8, and then you make it as simple as possible. Now then you get to this. So what is the next step? Okay, of course you can use a so-called substitution. Trigonometric substitution can continue and evaluate, but in this section we ask you to step 1, simplify the function in the integral. Then you look for the answer in the table of integrals. Okay, and you find out the formula number 34. Okay, gives the answer. Okay, so this is going to be square root of 1 minus a half of u times square root of 1 minus u squared plus 1/2, right? And the sine, the inverse of sine u, and plus constant. Then you replace u by what? By u is going to be square root of 4 over 5 and times x. Okay, and then you replace the by square root of 4, and u is going to be square root of 4 over 5. So actually u is going to be 2 square root of 5x. Then you have to replace it by this. Okay, after you simplify, this is going to be 1 minus 4x squared over 5. Right? This is and plus constant. Right? So that is answer. Now, are you able to get this? Are you able to evaluate this integral? The answer is yes, if possible. You can use a trigonometric substitution, because when you see 1 minus u squared, you can use a substitution to evaluate the integral. Okay, but that is for example, if I ask you to evaluate this integral without using the table of integrals, and how do you do that? Okay, you cannot just put the answer there. I cannot give you full credit to say, because you're open book right now. Open book, right? Open book test. So You cannot just copy the answer from the backside. You have to grab this. But that's use a very standard method because the square root of 1 minus u squared as the standard substitution is u equals sine theta. Okay, u equals sine theta, then du equals cosine theta d theta. Okay, and here theta is between pi over 2, negative pi over 2, so theta can be expressed as the inverse of sine u. Okay, so you can solve for theta. Right, then, oops, where's my? Can I find it? So, okay, it's here. Okay, then you replace u by sine theta, and the denominator is the square root of 1 minus sine square theta, and du equals cosine theta d theta. And you will see that these two will be canceled out. The reason is the denominator here is going to be cosine theta. Okay, yeah, the denominator is going to be cosine theta. So you just evaluate the integral sine square theta. It's not too bad, right? How do you do that, right? This is we did it many times. It's going to be 1 minus cosine 2 theta d theta, right? Okay. And then the antiderivative, when half is half of theta, the antiderivative cosine theta is sine 2 theta divided by 2, then it's 4, and plus constant. Okay. Now, can I change it to u, right? Because theta is going to be the inverse of sine u. Okay, right? So how about sine 2 theta, right? We know that sine theta is going to be u, but actually cosine theta is the square root of 1 minus u squared. Okay, the reason is it's a square root of 1 minus sine squared. So you can okay, and the sine 2 theta is going to be 2. It's going to be 2 sine theta cosine theta and divided by 4. Okay, so sine theta is u, cosine theta is the square root of 1 minus u. Okay, this is how do we get to the formula given in the book, in the back side of the book, called table of integrals. Right. So it depends on problem. If I ask you to use the table of integrals to evaluate the integral, then all you have to do is try to use a substitution and to simplify it to the simplest form. Then you look for the integrals in the back side of the book. If you find the one, then you can solve it. Okay. You can get an answer right away. Okay. All right. So let's take a look at the next problem. Yeah. Here I have an integral of a square of x. Okay. So this is the integral, right? So when you see this integral, it is natural to use a substitution right? To use a substitution, okay? Right? So you don't like a square x here, so you let u to be square x the first, and then du equals this. So what I'm going to get to here is this is square x. Yeah, so dx is going to 2 square x du. So it's 2u du, okay? So every term can be expressed, it can be changed. So we're going to get u here, arctangent to u, okay? And 2u du, okay? So let's rewrite this again. Okay, so now, so now we get to this point, okay? And are we able to get, we try to use a table, table of integrals on the back side. So we look for any, we try to find some formulas there, okay? Are we able to solve it? Yes, I do find one, okay? That is a number 95. Okay, number 95. Okay, number 95. If you're told that you can use a table of integrals to evaluate, then you have to use substitution first. Then, yeah, number 5. Yeah, number 95. That was the formula given is integral of u to the power n and arctangent of u du. So n here is 2, okay? N is 2, then you just write down, okay, the formula. Okay, let's see. 2, okay, the integral n is 2, so it's 3 here, n plus 1, and the u cube. Okay, and that's going to be u to the u cube. Okay, 1 plus u square du. Wow. Now you face another problem. It will be u cube over 1 plus u. Now, are you able to continue use some of the formulas so to save you time? So denominator is 1 plus u squared. Okay. Yeah, you have to search for that one. Okay. If you cannot find it, then you yeah, it's a 1 plus u squared. I don't think I have a formula here in the back of the book. If you couldn't find it, then you have to solve it by yourself. Okay. Evaluating integral of this. Okay, problem is this is a yeah, I'm just search for that. Okay, search for the formula. So far, I haven't found it. Okay. Nope. Better luck. So we have to finish this part. Okay. All right, so this is just a rational function, right? So to integrate a rational function, how do you do that? Right, you have to simplify first because the degree of the numerator is larger than the degree of the denominator. So that's u. So right. So u plus u cube and the subtraction is minus u. Right. So that means u cube of 1 plus u square is a quotient of u. Okay. And minus u over 1 plus u square. Okay. So you put the integral du. Yeah. du, and du. Right? So the first term is half of u squared. The second term is actually half of the natural log of 1 plus u squared. Because when you differentiate, the denominator is 1 plus u squared, the numerator will be 2u, and you divide by 2, you get u. Okay, so I write down the answer quickly. Otherwise, you have to use another substitution. Right? So, so then you go back to, you put the answer here, then you get the, yeah, then you get the complete answer to the original problem. Okay? If you cannot find the formula, you have to do it by yourself. Even in the in the problem, I say use table of integrals to evaluate this integral. Use table of integrals to evaluate this integral. You try to simplify by substitution. Then you may able to apply the formula. Then you still end up with another integral. You have to do it by yourself. If there's no formula, you can find out. Right? Yeah, I don't see any formula we can use here. That's why. Yeah, that is why I have to use a, have to use the idea, just simplify the ration function by the long division. Okay, so let's try another problem. This time it's a little bit simpler. So still it's tangent, inverse of tangent, square x, and then the square x dx. Okay, let's try this. So the substitution is still same. I use that first. So I end up with, I think I end up with a 2 times the inverse of tangent u. Now for this one, do we have the formula in the back of the book? Because this is the integral of a single function, and the answer is yes. Okay, it is formula 89. Okay, use the formula 89, so you get 2 is a constant here, right? Let's take it out. So it's a u of this. Okay. Then you have to replace u by square x. Square x squared is just x. All right. Now, if you're told you cannot use a table of contents, table of the integrals to evaluate this integral, then you still begin with a substitution. But then you get the integral of arctangent u, right? Integral of arctangent. You have to show me the details. How do you get that formula? Okay, you cannot just put the answer there. Okay, on the test, on the quizzes. Okay. Yeah. So how do you evaluate this good exercise? How to evaluate the integral of arctangent tangent x, right? You have to use the integration by parts. Okay, the integration by parts. Okay, you have to integration by parts. So how do you do that, right? So this is a u, that's a dv, kind of, right? So v is x, so u times v, so it's x times this minus, you switch the order, x. The derivative of arctangent x, just 1 over 1 plus x dx. So it's not too bad. That's just one trick again, use integration by parts. then yeah, integration by parts, okay? Then this integral, you know that if you want to use substitution, let w to be 1 plus x squared, then dw equals 2x dx, okay? So that will be half of dw and over w, okay? If you want to skip that step, that's okay. If you're very familiar with this type of integral. So it's just natural log of w, and which is 1 plus x squared. W is 1 plus x squared, so plus comes. So you get that formula immediately. It does not take too much time. Okay, only 3 steps. Okay. But for exercise in this section, you don't need to do that. It's already, you know, the integral is already given in the back side of the book. All you have to do is just copy it here. All right, our next problem. Okay. Well, when you look at this, I think it's also natural to use this substitution to simplify. U equals e to the x, right? So du equals the derivative e to the x itself and dx. So this part is just du. And here's 4 minus u squared. And I think you should normalize, you should use another substitution, let u to the 2w when you square it and get 4, right? So du equals 2dw, and here's a 4 minus u is 2w, so it's 4w squared. So after you simplify, you get to the standard form. Now, you don't need the table of integrals on the back side of the book. Okay, if you want, you know, this is just what? How do you get the 1 over 1 minus? What is it? What? It's given. It's, I think it's hyperbolic tangent x, the inverse. The derivative inverse is going to be this. Okay, so it's already in the book. Okay, all you have to do is just write now. Remember, what is the derivative of hyperbolic tangent x? Right, so derivative of hyperbolic tangent x is given where it is page. So we let me go find the page number. It's here. Yeah. So this is given in the, we know the derivatives. Yeah, so it's going to be okay. That's it. All right. Then you replace w by half of u. Then you replace half of u by e to the x. Okay. So that is the answer. And the hyperbolic tangent, inverse hyperbolic tangent x is just half of natural log, you know. That's another way to describe it. Okay. But but we prefer not to express the answer in terms of hyperbolic, inverse hyperbolic tangent x. In that case, you have to use natural log. Okay. But I'm okay if we put answer like that. I just call it answer. And this is not a brand new function. Okay, the inverse hyperbolic tangent x is not a brand new function. You can always replace it by half of natural log, 1 plus w, 1 minus w, okay? All right, so now let's take a look at another problem. Integral of x square root of x squared plus 2x plus 4 dx. Wow. All right, how do you solve this problem? You cannot find the answer directly from the table of integrals. You have to do something, right? Substitution, x squared plus 2x plus 4. There's this part. Yeah, we call it completing the square. So x squared plus 2x, you have to add the 1, so can combine them, right? Then 4 is become 3, right? Then you get x plus 1 squared plus 3, okay? So it's natural to use a substitution, let u to be x plus 1 first. And this integral becomes, what is x? X is u minus 1. And here u squared plus 3 du, okay? Wow, how do I evaluate this integral? Okay, so there'll be two parts here. Okay, I'm trying to use a table of integrals on the back side to evaluate it. All right. I don't see the first one, okay, because it's so simple. You just use a substitution to evaluate, so it's not given. Okay, so then we have to evaluate the first integral by ourselves. Okay, I do see in the formula when u here has become u squared, but if just a simple u, I cannot. There's no formula I can use. So in this case, there's a simple integrals substitution you can choose, right? For this one, yeah, okay, that's the first one, right? So I let w to be u squared plus 3, so dw equals half of u du. Right, so it's integral. This is w to the 1/2. U times du is half of dw. It's not too bad, right? So the entire derivative of this is 1/2 plus 1 and plus constant. Right, it's going to be 1/3. Right, and w is going to be u squared plus 3 to 3 over 2 plus constant. So we value the first one. The second one, okay, the second one, the integral of a square plus 3, right? Do I have a one? Yes. The answer, this is a formula number 21. Okay. The formula number 21 gives you the answer. It's half of u square root of 3 plus u squared, because that's going, the formula. Here we just 3, not square, because this is square of square root of, right? 3 plus 2, 3 over 2, natural log u plus 3 plus u squared, okay? Plus constant. So you don't need to waste time to evaluate this integral. And that's what you get. Okay. Now, if you try to evaluate this integral without using the table of integrals, how do you do that, right? There are a couple ways you can think about. One is use a substitution. Another one was using integration by parts. So you can differentiate the integral and you change the integral to, let's see, yeah. But you still have to use another formula. Yeah, so it's not a big deal. Yeah, I just said that you can change, the integral of a square plus 3 du, right? By integration by parts. There's two parts here, so it's going to be, right? Minus, and then switch the order, okay? This is going to be u times the derivative of that square root of u squared plus 3, and that is just u and du, okay? Right. Then you have to, so derivative of square of u squared plus 3 is going to be 1 u over 1, u over square of u squared plus 3. As a derivative of u squared plus 3 is going to be, okay. Then what are you going to do? And the numerator is just u squared, right? But u squared, I can plus 3 minus 3 here, okay? So square of u squared, and this becomes square of u squared plus 3 du. It's the same way, right? And then plus 3 integral of, right? And then you still have to find out the value of this integral, okay? And if you're not able to evaluate this integral, then then you're in trouble, right? Now, if you cannot use a table of integrals on the back side of the book, is there any integral? Is there any derivative? Any function whose derivative is going to be 1 over square u squared plus 3? The answer is maybe, right? So remember the square root of, so the inverse function usually come from the inverse function. Now let's take a look at, do we have those formulas in the book? Okay. The answer is it's hyperbolic sine x, okay? So you have to use hyperbolic, the derivative of inverse hyperbolic sine x is going to be that, okay? Now use that, you are able to evaluate that integral, okay? But the inverse function is also given by, okay? I think now you can evaluate that integral, but it involves several steps, so, it's not trivial without using the formula in the table of integrals. Okay, so the idea is that you use the integration of parts first. This is the technique. Then you end up with, this is still the original, right? But you can move to the right hand side, and it becomes 2, then divide both sides. So key point is you have to evaluate this integral, and that is that is actually the hyperbolic, the inverse of hyperbolic sine u. Okay, and the constant 3, you can use another substitution to get rid of 3. So you are able to evaluate this integral by yourself. Okay, and then your question is, when I cannot use the integral by part, the integral of the table of integrals, or when I have to do it by myself, when do I have to do it by myself using the basic formulas, in chapter 7. Well, unless I say you can use a table of integrals, okay? Otherwise, you cannot use it. Right? You have to use some substitutions or integration of parts to evaluate it. Okay. So let's go back to this problem again. After we, where it is. Yeah, I did not give the original answer yet because this should be expressed in terms of x. So I end up with two integrals. That's the first integral, that's the second integral. They are both expressed in terms of u, right? And then I have to replace u by x plus 1. Okay, then you get the right answer. Okay, then you get a complete answer, solution, complete solution. So don't forget to express the function in terms of x. Right. So here's another one: x squared cosine x dx. Okay. All right, so x squared here, okay, without using table of integrals, how do you do it? Well, you don't like x squared, so you use the integral by parts to reduce the power of x. Okay. Now then you search for the formulas in the table of integrals, and you see that formula 85, maybe you can use it. Okay, so that's going to be x squared sine x. Well, there's no integral symbol here. Okay, minus, that's 2, and x sine x dx. Okay, n equals 2. Okay, then you continue use the formula given in the book, right? So integral of x times sine x is going to be negative x cosine x plus 1 is, then it's cosine x dx. And then you know how to evaluate integral of cosine x. Okay, integral cosine x is sine x and the plus constant. Okay, so that's it. Okay, so we just use the formulas over there, eventually get an answer. Okay, I'm not going, we can, okay, step by step, I can reduce the power of x squared directly using integration by parts. But for this section, we just use a formula if possible. Okay. Yeah, we just use a formula if possible. Yeah, that's just lots of formulas here. All right, so let's take a look at the next problem. The integral of x squared natural log of x dx. Now, without using table of integrals, suppose we're not going to look at it right now. What are you going to do? You don't like natural log inside, right? In the integral. So you have to differentiate to get rid of natural log x. So you have to use the integration by parts. Then you can solve the problem. Okay, we try that. Okay, then maybe we can translate it. Okay, but maybe we can solve it using the using a formula in the table of integrals. So I look, and finally I find the one. This is a formula number 101. Right, 101. So n equals 2. So that's why it's x cubed. N equals 2, so 3 squared. Okay? And the n equals 2, so 3 natural log of x minus 1 and plus constant. That's it. So we can quickly write down the answers. 1/3 of x cubed natural log of x minus x cubed is over 9 plus constant. Right? Pretty fast. Okay. Now, if you cannot use a table of integrals, so if we cannot use a table of integrals, what are you going to do? Okay. Well, you have to get rid of the natural log of x, right? So it's x squared natural log of x dx can be written as natural log of x squared dx. This is my u, this is a dv. So when I switch the order, that's supposed to be uv minus v du, right? Then if I differentiate natural log of x, I can get rid of natural log. Okay, the question is what is v? Clearly v is 1/3 of x cubed. All right, when you differentiate, dv is going to be x squared dx. All right. So so now, right, use it, right? So it's 1/3 x cubed natural log of x, okay, minus v is 1/3 x cubed du, right? U is going to be natural log of x, so du equals 1 over x dx. It's 1 over x dx. Okay. So I get, so there's my 5. Touch different. Just a second. Okay. Okay, that's the derivative of u. Du equals 1 over x dx. Okay. Then you get, oh, I think it sounds like it's the end of the class. I hate this. I don't know what happened. Let me be careful if I finish this problem, okay? Okay, let's see. So you just evaluate this integral, and then this is just x squared. So that's why the integral of x squared is just 1/3 of x cubed, so plus constant. Okay. So without using a table of integrals, we are still able to evaluate the integral without too much trouble. You have to learn how to, many of the formulas in the table of integrals, you should be able to get, okay? And just use substitution, use integration by parts, and also use the basic formulas given in the book. You can get all of these formulas, okay? I remember when I was a student, after finish the homework, I just tried to derive all these formulas on the back side, similar formula. Okay, it's not on the, and that's for practice. Yeah. So here's the point. How to study calculus, right? Now, calculus is quite different from pre-calculus. Yeah, this is different students have a different math background. Some students take a little bit longer time to understand. Some students, spend less time. Okay, spend less time because he already spent more time when he was in high school and pre-calculus. So that's why he can spend less time to understand material. But there's no trick to learn math quickly. All I have to do is to practice, do more exercise. Sometimes you have to spend more than 20 minutes, even some particular problem have to come back again, and the total, you do need this time. Then after doing enough exercise, you know how to do it. It doesn't matter which problem I give to you, you can quickly get an answer. Okay, that's my personal experience. Okay, you can claim, say, oh, no, I'm not good in math, but does not mean you cannot study math. You can, in my opinion, 90% of the people in the world can get a PhD in mathematics if they're devoted to do that. Okay, that's probably my case. Okay, and that's my personal experience. So when I got to the Department of Mathematics as an undergraduate student, I was probably the first test I got the lowest scores on the whole class, I guess, because so many of my classmates are so good. Okay. Well, I thought I'm stupid, right? I cannot give up. So what I did is I do my best, trying to finish all the homework on the back side, at the end of each section. And I also did the extra problems. I went to the library, get a text, get another book. There was different problems, and finish all of them. And at the end of the semester, I got 100% on the test. Okay, and that's my personal experience. Okay, so many of you majors are in engineering, so you're probably the best student on campus. Best student in mathematics on campus. Okay. I hope everybody can pass this course, get decent scores, and then some of you haven't got into the program yet, like the Department of Mechanical Engineering and electrical engineering. That will look at the test scores on the calculus courses. Okay, not everybody. They're not admit to everybody. Okay, so this is so do your best to finish the homework. If you have a time, spend extra time, to complete other odd number problems. So that means then even you can always look at a textbook. You can quickly get the idea without looking through the books, because the problems are different. Maybe you cannot find the solutions within, you cannot find the formulas within given time. That's probably, if you're not practice enough. In the emergency case, yes, on the test, on the quiz. During the test, it's an emergency case. Okay, if you do not practice enough, you cannot quickly solve the problem. That's why even, you know, it's everywhere like that. Even military, right? You have to do exercise a lot until, you know, emergency case, you know how to use the weapons. Right? But exercise, so the section 7.6 is just integration user tables and the computer algebra systems. We're not going to ask you to use a compute algebra systems. Okay, so we're not going to do that. We only use we only just try to simplify the integrals by proper substitutions. Then use a formula. Use a formula in the table of integrals. Okay, and then you don't need to spend, instead of spend, you know, half hour to evaluate integral, now you only spend 10 minutes or 5 minutes, because on the way to what is the final answer, you already get the integral which you can apply the result, okay, in the back side. So you don't need to waste the time. All right, let's see what is time right now. We're almost almost done. Let's do one more exercise and we're done. Okay. So we have let's see. I'm going to take a look at the problem number 10 from the book, for example. Okay, 2y squared minus 3 and y squared dy. Okay. So when you see an integral like that, you don't like the constant 2 and 3 there, right? The first thing you have to do is use a substitution. You have 2y squared minus 3. If you take 3 out, you get 2 over 3y squared minus 1. So the substitution, right, is clear. You can let u to be square root 2 over 3y, okay? So using that substitution, and you will get, I think I'm going to take a square 3 out. Yeah, then that's u squared minus 1. And what is y? Y is a square of 3 over 2 u squared. And what is dy? Dy is also going to be 3 over 2 du, right? Yeah. Okay, you just solved for dy, right? So, so the constant you're going to get here, and that's square root 2 and the square root 2, okay? U squared and du. I already cancel 1 square root 3 over 2. So square root 3, it's, after you simplify, you get this. Okay, so now it's clear, right? It's clean. No constant 2 or 3, only 1 is the simplest constant in the world, right? Then you go back to the book, backside of the book, you know, can you, I don't want to do the further simplification in order to, where's the formula, right? Table, yeah, okay. So, yeah, do we find the formula over here? It says the numerator should be square root, right? As a denominator is u squared. Unfortunately, I don't see any of these formulas here. Okay, let me double check. Okay. Oh yeah, I do have it. So that is a formula 42. So we're lucky, see? So get formula 42, then yeah, A is always a 1, right? So you can write down the answer here. Square root over u squared minus 1 over u plus h log absolute over value u. Okay. Okay, plus constant. Okay, then you have to change u to square root 2 over 3 times u times y, yeah. Right, so you can simplify a little bit. It's not a big deal. Okay, you have I don't know. You can just leave it like that. This is the answer. Okay, this will be the answer. So it's clear that, right? Just use a simple substitution. Then you change it to an integral where you can find the formula in the table of integrals, which is number 42. Then you apply that formula. Then you get right answer. Now, what happens if you cannot use a formula? If you cannot use a formula, there are other substitution you can use. Okay, maybe use a substitution. So u squared minus 1, that is a standard substitution there, right? The formula probably you can use is 1, you see, hyperbolic cosine x minus theta x minus hyperbolic sine x equals 1, right? So something square minus 1 equals another square, right? So maybe use a substitution, you can use hyperbolic cosine theta, okay? Then you simplify the integral and you probably can evaluate, okay, this integral. That's just one of the substitute. You know, it's come to my mind naturally, use substitution. Okay, this is a, you will get the same answer, okay? But if you are allowed to use a table of integrals, then you just write the answer, find the corresponding formula. Okay, so that's all I'm going to talk about today. Maybe you are given, you know, one quiz problem, ask you to use a table of contents. Okay, table of integrals, sorry, not table of contents, table of integrals to evaluate integral. Then you use a table of integral. If you are not given that word, and please do not use a table of integrals to give me the answer. Okay, I want the solution, detailed solution. All right, that's it. Let's stop again today.